everyone, welcome to this video. In this video, we shall see a question from again December 2016 consisting of 3 marks. The question is, let phi satisfies this equation. Phi of x is equal to f of x plus integration from 0 to x sine of x minus t phi t dt. Then phi is given by which of these 4 equations, integral equations, right? So it is pretty simple question. So we can solve it by multiple methods. Just look at what is the kernel. The kernel here is sine x minus t. So we can expand this kernel like sine x cos t minus cos x sine t. So this becomes separable kernel, and then we can apply the techniques thereby. That means the solution for this equation could be given in this form. Phi of x is equal to f of x plus lambda. Lambda is given to be plus 1 in this question. Integration the resolvent kernel ft and dt, right? Where what is this resolvent kernel? It is given by d s t lambda divided by d lambda. So for that you need to calculate this the determinant of this matrix and this matrix and then divide both to get resolvent kernel. Another method is that the kernel is sine x minus t. So it is also of the convolution type. That means our given integral equation could be written like this: phi of x as such is equal to f of x as such. This term, the integration from 0 to x sine x minus t phi t dt. So this term could be written as sine of x convolved with phi of x. So this is the convolution operator. This is the convolution operator, right? So after that we can apply Laplace transform, then apply inverse Laplace transform, and then we can reach at the results. But there is a more easier way to solve this question. We can convert the given integral equation into the corresponding ordinary differential equation and see which option matches with the given differential equation. So first of all, this is our given integral equation, right? Let's solve it by converting it into the ordinary differential equation. Let's differentiate this, right? So we can differentiate equation number 1, this one. So it will give phi dash x is equal to f dash x plus, here we have to apply Lebanese rule of differentiation under the integral sign. So it is what? It is integration, then the partial derivative of this term. What is the partial derivative of this term with respect to x? It will be the derivative of sine, that would be cos x minus t as such, and then the derivative of the angle, that is 1 minus 0. So it is just cos x minus t phi t dt as such because they are independent of x. Then what we do? Plus the derivative of this upper limit with respect to x, that would simply be 1 into this whole term where we replace t with the upper limit, that is x, and minus again the derivative of the lower limit. What is the derivative of lower limit? It is 0, so whole terms become 0, right? So this term also becomes 0. Why so? Because x minus x0 sine 0 is 0. So we have this equation. We again have to differentiate it because there is this integral term. So here we have phi double dash x, f double dash x, the twice derivatives, right? And here we will again apply the Lebanese rule. That means integration from 0 to x, the derivative of cos x minus t, it is minus sine x minus t. So minus sine x minus t, and the derivative of x minus t partially with respect to x is x, phi t dt as such, plus the derivative of upper limit, that is 1 into cos of x minus the upper limit x, phi of the upper limit x, right? And minus the term, this one, the derivative of this lower limit. So that would be 0. So we reach at this equation. Phi double dash x is equal to f double dash x plus f of x. So mark this as double star, right? So this is the given integral equation which we have converted into the ordinary differential equation. So now look at our options. We'll convert this and this into the corresponding ordinary differential equations, just in a very similar way as we did for this equation, right? So and we'll match up the results, whichever of these four matches with the given integral equation, that is the result, that is the answer. So let's go for solving the options. So let us look at the first option. It is phi of x is equal to f of x plus integration 0 to x minus t ft dt. We can differentiate this. We'll obtain this. And then we can double differentiate it. We'll obtain this. I hope you can do it now. Right? Following the same steps as discussed above and applying the Lebanese rule. Let me just write the Lebanese rule for you. It is the derivative of with respect to x of some integral, say uxt dt, right? This would be equal to integration from 0 to x, the partial derivative with respect to x of uxt dt, plus the derivative of upper limit, say here it is ax and here it is b of x, right? So in that case, it would be the derivative with respect to x of the upper limit multiplied by this whole function evaluated at the point ax, the upper limit, minus the derivative of the lower limit b of x, and this whole thing multiplied by u, where we replace this t by the lower limit b of x, right? This you should know by now, right? So this is the rule. So clearly you can see that this term matches with this term, right? So option A is the correct option as of now. Let's because this is a single correct option, so we can stop here, but for the sake of completeness, let's check all other options also. So the other option is this. So when we differentiate it twice, we obtain this, which is not equal to the one that we obtained earlier. Similar is the case with the part C and part D. Here, while solving part C, when we first differentiate it, we have something like this. Cos of 0 is 1, so this term is minus f of x. And when you differentiate it again, you will get something like this. Now this term, can you see? What is this term? This term is simply f of x minus phi x. Just rearrange this equation a little. You'll get this thing, f of x minus phi of x. So this is also not equal to the one that we have calculated for our equation. So this is also not the correct option. And let us see for the last one. Similar is the case with this one. So here we have differentiated once, then twice, and we obtain finally this equation. So this also does not match with the one that we have calculated earlier, which was this one, right? This one. So clearly option A here is the correct option. So option A is the correct option. That is it for this video. Thank you for watching.